Hey everyone, welcome to this session. Our topic is extractions of metals. We are still discussing about the properties of metals. In our past video, discussed some of the properties of some common metals. We saw the tensile and their reactivity strengths. So today we'll move on to more of these properties of metals. We'll be discussing about the oxidation and the reduction. So, as we said earlier, that the metals tend to lose electrons during the chemical reactions. Now, this process of losing the electrons is what we call the oxidation. The metals normally lose these electrons to the non-metals when they react. Now, which these non-metals are the ones that accept those electrons. Therefore, metals are said to be electron donors, while the non-metals are said to be the electron acceptors. Now, in this case, you can term these metals as the ones that they lose electrons to nanometals as the reducing agents, because they are the ones that they donate the electrons to the nanometals, which whereby when the non-metals are the ones that are receiving, so they are recipients or acceptors. So this way we can differ between metals and the non-metals. Now, non-metals from this case, they are called the oxidizing agents because they oxidize or they increase the oxidation number of the metallic atoms through accepting the electrons donated by the metals. Now, metals differ in case of their losing property of the electrons, that is the oxidation, depending on their electronic configuration. In the past video, I hope we discussed about this electronic configuration, specifically how to locate the various elements within the periodic table. Now, why do these metals differ in case of losing electrons depending on the electronic configuration? This is because it is only the outer electrons, which we said that they are the ones that are found on the outermost shell of an electron, which are the ones that take part in a chemical reaction. Now, the nucleus of an atom being positively charged normally attracts the electrons towards itself, since the nucleus is positively charged while the electrons are negatively charged. So the nucleus attracts the electrons to itself, hence making the electrons differ to remove from their shells. That's why you cannot remove electron from the first shell or second shell, etc., etc. But only those on the outermost shell. So the further the electrons are from the central nucleus, the easier it is to remove them from their shells and vice versa. Therefore, atoms with the larger atomic radii, that is the distance of the last electron from the outermost shell to the center of the nucleus, donate their electrons more easily than those with the small atomic radii. Now take an example when you are comparing the electronic configuration of sodium, that is 281, with that of potassium, that is 2881. The sodium ionizes by losing one electron from its outermost shell to attain the structure of the nearest noble gas, that is 280. Likewise, the potassium also ionizes by losing one electron from its outermost shell to attain the noble gas structure, that is 288. But in which of the two cases it is easier to remove electron and why? Simply because it is easier to remove the electron from the outermost shell of the potassium than sodium, because the atomic radius of the calcium is too large as compared to that of sodium. By this case, it means that the calcium, the outermost electron is more loosely held by the central nucleus, and hence it's easier to remove from its shell. Now, this is true because the ability of nucleus to hold the electrons firmly depends on the distance of the electrons from the nucleus. Metals that release the electrons more rapidly are said to be strong reducing agents compared to those that release the electrons least readily. Take an example. Uh, when we are talking about potassium with the electronic configuration of 2881 with a stronger reducing agent than sodium, which has an electronic configuration of 281. Therefore, it is clear that when the atoms of the elements lose electrons from the outermost shells, they obtain the octet or the duplet structures, and hence they become chemically stable. Now, it's not easy to remove electrons by ordinary chemical means from such stable gas structures. Now, from the context of the above explanations which we have discussed here about the oxidation and the reduction of the various elements, considering the use of electronic configuration, the reducing power of the metal can be defined by its readiness to release electrons from its outermost shell. Metals whose atoms release electrons more readily have higher reducing powers than those metals whose atoms do not readily release the electrons. So thank you guys for listening. I hope it's clear. We've discussed the simply about the oxidation and reduction. We've seen how they can be obtained as some of the properties of the metals. Thank you.